Welcome back. In this video, you're going to see what is object-oriented programming. Obviously, this is going to eliminate the drawbacks which we faced in procedure-oriented programs. Let us see how this is going to do. So, as I told, the object-oriented program is going to remove few drawbacks, which cannot remove all the drawbacks, but which is going to remove few drawbacks which we encountered in POP. So POP stands for procedure oriented programs. So what happened is we focus, as the name says, we focus on data rather than procedures, or we focus on objects. Second thing is so there is a restriction for data movement. Data cannot move freely around the procedures or systems, and data is more closely associated or attached with the systems, which ties uh, object oriented program ties data very closely to the function, so that accidentally or any non-member function, unwanted function cannot access it. And the last point is no function exists without data. So data is going to be the, or which is going to play a very important role. Without data there is no functions. And the last point is which follows bottom up approach, wherein POP we have a top down approach. The difference is, what we do is in object oriented program, first we are going to create objects, and data and function will be created around them. Let me repeat. First we are going to create objects, and for every object there'll be functions and data. So this is going to be created later. So let us see the diagram for this. See, we give more importance, as I told. So this is what the object. Every object contains data and function, and as you could see on the picture, data and functions are tied together. Data cannot move very freely. You can see the same for the second object, where you can find the object as B. Yeah, as well here also the data and function are tied together. So let us see what are the main features of object oriented program. So there are five features. One is message passing. Second one is polymorphism, inheritance, data abstraction, and encapsulation. So these are the basic concepts of object oriented program. Apart from classes and objects, we have message passing, polymorphism, inheritance, data abstraction, and encapsulation. So let us see what is an object. So object is nothing but it's an entity. So runtime entity, which can be anything like your name or your class, your roll number, your division, anything can be an object. So object occupies the same memory as variable, and which is going to have its own address. So when we execute a program, uh, the object interact by message to another. Let me repeat. So your program, your task is divided into objects. When we execute, the objects interact by sending message to another, which means objects need to interact each other. This happens by sending the messages. For example, think that you have got two object. One is no, the customer, and the second one is account. So obviously, no, the account need to send a request to the customer to know the account balance, which can communicate. So let me brief. Every program is divided into a collection of objects, and objects contains functions and data. They are tied together. They are not allowed to move freely through the system. And during execution, the objects need to interact by sending messages. So yeah, you could see, uh, if you look at the screen, you can find an object called student. Object contains data. The data can be their name, their date of birth, their marks. Everything is going to be the data. And function is something like to find what is the total marks they have got, what is average marks they got, or function to display their information, student information. So this is about object. So objects can interact without having to know details of each other's data. So think that you have got two objects. Your program has got two objects. We'll take it as A and B. So object A can communicate with B without knowing B's data or its code. So let us see the next important thing, which is class. So class is is a collection of objects. You could see a class on the screen, and we named it as car, where you can find methods. The methods we call it as the functions, and we have got other attributes like fuel and its maximum speed. If you take a car as a class, so we have methods like get speed, set speed, the drives, their fuel and speeds, everything. So the entire set of data and code of an object can be made a user defined data type with the help of a class. So we can create a class using this. So let me repeat, what is a class? It's a collection of objects of similar type. So next, let us see the next feature of object oriented program, which is encapsulation. So encapsulation, as the name says, which is going to wrap up of data and functions into a single unit. So what happens when we do this, which is going to prevent unauthorized access of data, or I can say that which is going to provide data hiding. So which is something like we are familiar with the capsules. So we have no idea what is inside. Instead, obviously, medicines will be there. Same way, if you take object-oriented program where encapsulation takes place, instead you could find the methods. When I say method, I mean the function and the variables or data associated with that. So, which is going to provide a means of data hiding, or we call it as information hiding. Next important feature is data abstraction. So which represent an act by which the essential features are provided without giving the background details or background explanation. So, or we can say that which is going to separate unnecessary details or the explanation, and which provides only the required features. For example, if you take a car, we are aware how we can drive a car. But we are not worried, we are not bothered to know how a car engine works or how things happen inside the car when I change the gear. Everyone knows how to start the car, then how to change the gear, how to stop the vehicle. We are aware of all basic needs or basic functions. But what happens when when I change the gear? What happens inside the car? We are not aware. That is called abstraction. Or if you take the second example, if you take it as touch phones, mobile phones, touch screen, we are aware. Everyone is familiar with this. But what happens when I touch a screen? When I touch the screen of my mobile phone, how a particular application gets open, or what are the features which is hidden from me, or what are the features which is inside, what is the motherboard for this, how all the things works, we have no idea. And this is called data abstraction. So the meaning is representing the essential features without including the background details. Only the essential features will be provided. What happens in the background, we need not to bother, or we are not provided with that. So next important feature is inheritance. So every one of us has inherited certain properties from our ancestors or uh, parents or grandparents. Same way, when it comes to the object oriented programs, uh, an object of one class occurs properties of objects of another class. Obviously, in a program, you will have n number of classes, and for every classes, objects will be created. And think that you have got two objects, will take it as A and B. So object B can inherit certain properties from object A. So this is called inheritance. So, or we can say that if you take class A and class B can inherit certain properties from class A. So class A is going to be something like parent or grandparent, and class A is going to be, or class A is known as the base class, and class B is known as the derived class. So these are the few examples. So parents and child. So obviously the child might have inherited, or obviously it will inherit certain properties from the parents. To look at the lion and cub, cub will inherit certain properties from the lion. Same way, if you treat the class A as grandfather, B as father, and C as child, class B should have inherited certain properties from class A. Same way, class C might have inherited, or which can inherit certain properties from class C. In turn, I can say that class C inherited certain properties from class A. So in this case, we call class A as the base class B as intermediate class, and class C as derived class. So there are different types of inheritance. We can have a single inheritance, we can have a multi-level inheritance, so we can have hierarchical inheritance, we can have multiple inheritance, and we can have a hybrid inheritance. So the last important feature of object oriented concept is polymorphism. So polymorphism meaning I hope everyone knows, which means no having many forms, or we can say that its ability to take more than one forms. So it's an ability to access different implementations of a function using the same name. We can have function with the same name but different signatures of parameters. So you can you know a function which is going to add two integers, which is going to give integer sum, or you can have a function which is going to give again sum for two floating point numbers, or you can have a function which is going to concatenate, which is going to append two strings. So basically all these three functions does the same job, which is going to add, but which takes different forms at different intervals. So this is what the actual explanation for that. So addition operation which can add two integers, look at the file name which is add, or which can add two floating point numbers, function name remains same, and which can add two strings. So in all these cases your function name remains same, but what happens, your add function takes different steps, different forms, different parameters at different intervals. If you look at the diagram, see, everyone speaks: the man, the duck, the dog, the cat. But they everyone does the same job, but the way they speaks is different.